So for part B, the key to understand this problem is to get that the wave does not travel the same distance as it goes back and forth. So to understand this problem, we've chosen 3 moments in time that we're going to analyze one after the other. So first, the time t0 is when the submarine sends the initial wave towards the wheel. As you can see, at the time t equals t1, the wave is received by the wheel and bounces back on it and goes back towards the submarine. But as you can see, during that time interval, the wheel traveled the distance, so the wave in reality did not do the whole length from the submarine to the wheel because the wheel traveled during that time. Then, same principle for this bouncing wave. The submarine will have traveled during that time interval, which means that the wave will only reach it here. Now the key is to get that the full length traveled by the wave is this distance here d1 plus this distance d2. Now we don't know what this distance is, but we know that the wave took 0.4 seconds to travel that distance, and the sound was going at a speed of 1500 meters per second. So with those informations, we can find this distance, which is going to be 1500 times 0.4 seconds, which is going to give us 600 meters. So the total distance traveled by the wave is 600 meters. Now, what we're looking for in reality is the distance here between the wheel and the submarine at t equals 0.4 seconds, because that's when the crew receives the signal and that's when they have the time to react to this signal. So that's the time interval they have before the collision. So we want to calculate from that point what is the time until the collision. So now we've found that d1 plus d2 is 600 meters, but we haven't found any of them separately. But we're going to use this length here, d3, to find d2. So as you can see, d1 is simply d2 plus d3. Now we get that 2d2 plus d3 is equal to 600 meters. We have the speed of the submarine, and we have this time interval here, because it's from the moment the submarine sends the wave until the moment it receives it. So that's a time interval of 0.4 seconds. So we know that d3 is the speed of the submarine times the time, so 0.4 seconds, and so we get that it's 4 meters. So we know that 2d2 is 600 minus 4 meters, so 596, and so d2 is simply 298 meters. Okay, now we're almost done, but we still need to find an additional piece of information, which is d4, in order for us to find this distance here, which is what we're looking for. So to find d4, we're going to try to find the first time interval here. So we're going to need to find what is this t1. So to know what t1 is, we know that the wave traveled this distance here, d2, which is 298 meters in the second part. So from t1 to 0.4 seconds, it did 298 meters. And we have the speed of the sound wave, which means that we can find the time it took the sound wave to travel this distance. So 0.4 minus t1, which is this time interval, is equal to the distance traveled by the sound wave, so 298 meters, divided by the speed of the sound wave. And so we get that it took 0.1987 seconds for the wave to travel this distance d2. That means that t1 is 0.4 minus this time here. So now what we're going to look for is in that time interval, 0.1987 seconds, what was the distance traveled by the wheel? So we have the speed of the wheel, so we can do that. So d4 is going to be the time interval times the speed of the wheel, which is 33.7 meters per second. And so we get that d4 is approximately 6.695 meters. Now we've got all the pieces of information to solve this problem. We know that the final distance between the submarine and the wheel at the time at which the crew received the signal is d2 minus d4. And that's 298 meters minus 6.695, which gives us approximately 291.3 meters. Yeah, we're gonna just round up to 4 significant figures here. Okay, so now we just need to find the time before the collision, and we know that the wheel is traveling at 33.7 meters per second, and the submarine is traveling at 10 meters per second. So if we try to, let's say that delta x is the distance between the two objects. So delta x initial is 291.3 meters, and let's call v the speed at which this distance is decreasing. Well, in reality, this distance is increasing by a factor of 33.7 meters per second plus this 10 meters per second. So if we add both of them, we know that this distance is decreasing at a rate of 43.7 meters per second. So we can just use the absolute value to calculate the time it will take to travel this distance here with 43.7 meters per second. So delta t is going to be distance over the speed, and that's going to give us our final answer, which is going to be 6.67 seconds